understand superposition theorem and how it can be applied over here to find the current in this arm. Superposition theorem says, first you can just take one battery and short the other batteries and find the current contribution because of one battery. Then you can move to the next battery and find its contribution when this alone battery exists and no other battery exists, that is, they are short circuited. And you can find the contribution of current because of now this battery. You can carry on the process till you have found the contribution of current by all the batteries individually in a particular arm of interest. Over here, we are interested in finding the current through this arm AB. When we say first is we have to find the contribution of one battery, that is, first of all just consider one battery and short circuit the other battery. It means we consider, let's say, just one battery. First let's consider this battery only, and now when we say that this battery is not here, it is not that we just remove it like this and the circuit is open. No, we remove it and we connect these both the ends with a wire so that this is also a closed loop. Now because of this, we'll find a current in this wire and then similarly we'll short circuit it, and this battery will be over here. Because of this battery, we'll also find the current in this arm, and then we can simply algebraically we can add or subtract the currents. We can add them if they are in the same direction and we can subtract if they are in the opposite direction. This is how we are going to apply superposition theorem. So first, if we see that this is 30 volt battery, now we say this is a 10 ohm resistance and this is a 10 ohm resistance across, and we are interested in finding current in this thing. Let's say for a time being, to simplify it, we are just interested in finding the current in this. Let's call it as I1. Now I1 is the current contribution in this arm because of this battery alone when this has been short circuited. Over here we see these both the paths, they split over here and they meet over here. The current comes over here, it splits in both of them, and obviously this 10 ohm and this 10 ohm now they are in parallel. When they are in parallel, so this is equivalent to a circuit like this. So this is 10 ohm. When this 10 ohm and 10 ohm they are parallel, we know 1 by R is equal to 1 by 10 plus 1 by 10, 1 by 10 plus 1 by 10 is equal to 2 by 10. So R is equal to 5 ohm. So this is between A and B. We can have that this resistance is equivalent is 5 ohm. This is A and this is B, and this is 30 volt. Now we can directly apply Ohm's law. It says V is equal to IR. 30 is equal to I into R is 10 plus 5, that is they are in series. So current is equal to 2 ampere. It means the current which shall be coming out of the battery is 2 ampere. When the current is 2 ampere in this wire, so it means the current 2 ampere will be coming from here. When the 2 ampere comes over here, now when it reaches over here, it has two ways to go. One is this path, the other is this path. Both the paths, they have the equal resistance, so it means the current will be divided equally. Because both the resistance they are same, they are offering the equal resistance, so current will be divided equally in both the paths. So be it this arm, be it this arm, this 2 ampere is divided equally, so it means 1 ampere goes over here, and in this 1 ampere will be in this direction. So when we say 1 ampere, it is not the current, final current which shall be flowing in this direction. It is this 1 ampere is the contribution when there is only one battery. That is 1 ampere is the current in this direction because of this battery alone. Now what we do is, once we have calculated what is the contribution of current because of this battery in this arm of interest, now we short circuit it, and we find the contribution of other battery which is of 15 volt. Now this is 15 volt battery. We'll find the contribution because of this in this wire. So now this is what we had solved, that is gone. I remove this also, but I write it over here. That is because of this, it was 1 ampere in this direction. This is A and this is B. So over here we have written that is because of 30 volt battery, the contribution of current in this arm, that is 1 ampere in the down direction. Now we consider 15 volt battery and find its contribution in the current flowing in the arm AB. Now over here we see this is 15 volt battery. Current will come in this, current will flow in this direction from positive terminal comes over here. Now these two resistances 10 and 10 ohm, they are once again they are in parallel. So if we redraw this, so this is a 15 volt battery. This 10 ohm resistance is over here. This is A junction and this is B junction. Between A and B, this and this same resistance, equal resistances, they are parallel. That is what we did earlier. To find the equivalent resistance, 1 by R is equal to 1 by 10 plus 1 by 10. So they'll once again make a resistance, equivalent resistance of 5 ohm only. So this is 5 ohm. So when we use Ohm's law, V is equal to IR, V is equal to I into R. R is 10 plus 5, 15. So current comes out to be 1 ampere. So this is the current which shall be coming out of the battery in this direction. This is the current which shall be coming out. So it means, so from here, it shall be 1 ampere current which shall be flowing out in this direction. And when it comes over here, it divides equally in the two paths, because this path and this path, they are identical. Both of them, they are offering the same resistance. So for current, there is no reason to prefer one path over the other. So the current divides equally amongst both the paths. So if this is 1 ampere, so half ampere current goes over here and half ampere goes in this arm in the downward direction. So it means the contribution of current because of this battery alone in this arm is half ampere in the downward direction. So the contribution of this is half ampere. 1 ampere was contribution of this 30 volt battery in the downward direction. Half ampere is the contribution of this battery in the downward direction. So the total current in this wire is 1 plus half, that is 1.5 ampere in the downward direction. That is the answer we had got earlier by using Kirchhoff laws. Suppose this current, that is half ampere, had been, let's say, in the upward direction, then we would have said that the current in this wire is 1 minus half, because the direction is opposite. That is, it is half ampere in the downward direction. So this is how we use superposition theorem. So over here, without much fuss and without much writing equations of KCL, KVL, then simultaneous equations, we can directly get the answer. First we find the contribution of one battery, then what is the contribution of this battery in passing the current through this wire, and we can simply add it and we can get the answer